Good morning, dear students. Today we are going to study the last chapter of the chemistry, that is periodic classification of elements. Okay, students, there are 118 elements are present not today, and it is very difficult to study all these elements separately. So all these elements have been divided in such a way that the element which have the same property will put in the same group. Okay, so children, various attempts have been made for the classification of elements from time to time. Okay, the first we will start Doberneir triads. Okay, triads means children a group of 3 elements. This was the earlier attempts. In this, children, elements are classified on the basis of their properties. Okay, means there are certain elements which show similar chemical properties were put in the same group, and that is called family. Okay, so children, on that time Doberneir observed that, okay, and made a triad. Means he collects some of the elements which have same properties and put in the same group. These groups were known as triads, and these triads were showing similar chemical properties. Clear, children? So on the basis of its observation, he states that when elements are arranged in the order of increasing atomic masses, means when elements were arranged in order of increasing atomic weight, okay, that is known as triads, so they will show similar chemical properties. Clear, children? For example children, lithium, sodium and potassium. Atomic mass of lithium is 7, 23 and 39. Okay, so when these elements are arranged on the basis of their increasing atomic weight, so they will show the similar chemical properties and were put in the same group. Clear, children? And after that, the atomic mass of the middle element, okay, the atomic mass of the middle element is equal to the arithmetic mean of atomic mass of other 2 elements. It means we can easily calculate the atomic mass of middle element by the arithmetic mean of other 2 elements if we arrange these elements in increasing atomic masses. Clear, children? See, children, how can we calculate? There is a arithmetic mean of other 2 elements, means we will calculate the average of lithium and potassium. Arithmetic mean of lithium and potassium. Okay, so 7, 39, and it is divided by number of terms, children, 1 and 1, 2. So we will get 46 by 2 atomic mass is equal to the sodium. Clear, children? It means when we arranged increasing atomic mass of the element, we can easily calculate the mass of middle element by the average of other two elements. Children, Doberneir was the first scientist which had shown the relationship between properties of element and their atomic masses. Clear, children? Now, in second triad, the elements were calcium, strontium and barium. Atomic mass of calcium is 40, 88 and 137. Okay, these were the elements who were in the second triad, and they were showing similar chemical properties because they were arranged in the order of increasing atomic masses. So children, we can easily calculate the atomic mass of middle element by the average of other two elements. See children, arithmetic mean of calcium and barium, okay, is 40 plus 37 by 2. We will get 177 by 2. Clear? So children, the mass which we have got from this children, that is nearly equal to the strontium children. Clear? This was the second triad of this element. Now children, the third triad was chlorine, bromine and iodine group. Okay. Atomic mass of chlorine is 35.5, bromine is 80 and iodine is 127. These elements were arranged in the order of increasing atomic masses because they were showing a similar chemical properties. So children, we can easily find out the atomic mass of middle element by the arithmetic mean of other two elements. Okay, let us calculate the mass of middle element by the average of other two elements. So, arithmetic mean of chlorine and iodine, okay, 35.5 plus 127. We add by 2 children, so 81.2, and this atomic mass is nearly equal to the bromine children. Clear children? These were the three triads of Doberneir. Now we will see the drawbacks of Doberniers. Means what was the limitations of Doberniers? First children, he failed to arrange all the known elements in the form of triad having similar chemical properties. So write in your copy children, he failed to arrange the non-element in the form of triad having similar chemical properties. Okay, means children, on that time 56 elements were known at the time of Doberneir's. And how many triads he made, children? 3 triads. He made 3 triads. One triad contains 3 elements. So 3 triad contains 9 elements. Okay. So children, he failed to arrange all the known elements in the form of triads having similar chemical properties. Means the rest of the element were not explained by Doberneir's. Clear, children? That is why this postulate was not successful for the classification of elements, children. Now, children, second attempt was Newlands law of octaves. Children, octaves means the note from music. Okay. Newlands also arranged all the known elements in the order of increasing atomic masses. Okay. But children, he found that every properties of earth element is similar to that of first element. Okay. So on the basis of his observation, he gave the law of octaves for the classification of elements. Okay. He stated that when elements are arranged in the order of increasing atomic masses, okay, after that the properties of earth element are repetition, means similar to that of first element, means eighth property and first property will match together. See, children, how now these elements are arranged in the order of increasing atomic masses by Newlands. So let us check, children, how this happens. Hydrogen, if we take hydrogen, the first element. So children, there are 8 octaves in music. Okay, sa re ga ma pa dha ni sa. Sa re ga ma pa dha ni sa. There are 8 octaves in music. It means the property of 8th element, okay, is similar to that of first element. Clear? So children, sa re ga ma pa dha ni sa. So children, both are having similar properties. If we take this lithium as the first element, okay, so sa re ga ma pa dha ni sa, it means the property of lithium and sodium will match together. If we take barium, the first element, so sa re ga ma pa dha ni sa. Clear, children? So the property of barium will similar to that of magnesium. So on the basis of its, Newton gives the law of octaves. But children, we are seeing that there are some gaps which were left by Newton. Okay, these gaps were blank on that time because he stated that only these elements can be in the form of octaves. Clear? But children, we will see the drawbacks of Newton's law of octaves. Now children, we will see the drawbacks of Newton's law of octaves. Okay, his first drawback was this table was applicable. Okay, it was applicable only up to calcium. Okay, means after calcium, the property of eighth element were not similar to that of first element. Let's see, children. Suppose this is first element. Okay, sa, re, ga, ma, pa, dha, ni, sa. Atomic number 20 means it is similar to that, it's magnesium. If we take this first element, sa, re, ga, ma, pa, dha, ni, sa, means there are two elements. So these properties were not similar to that of first element. Clear, children? So first drawback was that it was applicable only up to calcium. Second thing is that on that time 56 elements were known. So he stated that only 56 elements will exist in nature. 56 elements exist in nature and no more elements would be discovered in the future. But children, later on several elements were discovered and they were not filled in the law of octaves. Clear, children? The third is there were some slot in the law of octaves in which two elements were put together, like cobalt and nickel. This one also, children? Yes. So children, when these elements, means two elements, were put in the same slot, these elements were not similar to that of these elements. Means the property of these elements were not similar to rest of these elements. It means unlike elements were came together in the form of octaves. Clear, children? So we can write unlike elements were put together having different properties. Okay, children? So we can say that these attempts were also not successful for the classification of elements. Okay, first it was applicable only up to calcium, children. Okay, if we take magnesium, first element sa, re, ga, ma, pa, dha, ni, sa, it is similar to that. But if we take aluminium, the first element sa, re, ga, ma, pa, dha, ni, sa, so in the same way after calcium the properties of its element were not similar. Second, 56 elements were known and he stated that no more elements will be discovered in nature. Third is very easy, children. So we have now completed the Doberneir triads and Newlands law of octaves. Clear, children? Thank you.